Hello everyone, welcome to the session. In this session, we are going to discuss about the log analysis. How the log analysis will help us to fine-tune our model. The log is nothing but it is a data generated during the training performance. Using that data, we are going to plot a graph as well as a heat maps, which will help us to identify the robustness of the model to continue our process. From where the log will be taken? So the log file will be available in your DeepRacer console. After the training phase has been completed, you will have a button which is called as a download log in an enable position. While you are pressing this download log, you will receive the log file which is in a compressed file format. This compressed file is consisting of a folder called log. Inside the logs, we have another training folder. In this training folder, we have two files. One is for log file for SageMaker environment and another log file for RoboMaker. We are already familiar that the RoboMaker will consisting of the simulation environment data, and SageMaker log file will have the policy update data. From the RoboMaker log file, we can identify or we can analyze the minimum progress, maximum progress, average progress, total reward, and what could be the time taken for complete the labs, whether the labs have been completed and how many episodes per iteration is happening. Everything we can derive from the RoboMaker log file. The SageMaker log file consisting of the details about loss, divergence, entropy, and the learning rate of each iteration, which will help us to identify whether the convergence have been met or not. If two models are trained for the same amount of time using the same reward function and hyperparameters, why do they have different lab times when I evaluate them? This is a common question will be available in all our mind while we practiced in this environment. The exact answer is given by visualization of the performance of lab completion in a particular time period. So this will help us to evaluate why the model is behave in this way. The convergence is the most important concept in the training phase. Convergence is nothing but at a particular point, the model is performing close to its best. The further training may harm its performance or make it overfit. How could we identify at what time the convergence have been occurred? We already have a clue in reward graph. Some more detail it has been explained in log analysis too. Entropy is a measure of the amount of randomness in our reinforcement learning neural network. At the beginning of the model training, entropy is high because it randomly generated an action. After a particular time of training, the model identify what action has to be taken. If the progress of completion as well as evaluation is fine-tuned, then the randomness of selecting the action is very low. That means entropy value should be very low. This has been explained in this graph. So it is a graph between an iteration and entropy as well as iteration and rewards, progress of completion and number of labs completed. So in this graph, the entropy is started in the minimum level and it is slightly increases and decreases and the curve is increasing. Like the plateau, it is increasing, then it starts to decreasing. So After decreasing to a certain period of time, again it start to increasing. So this is a place where we have a convergence. Once the entropy is getting decreased, it has to be in a decreased format, and after a particular time, it should be in a stable format. If it is not like that, if entropy is start to increasing, the model struggled to identify the exact action at this particular state, which will denote this is a place the convergence has been occurred. And this is a graph for distribution of action. We are having a lot of actions based on our hyperparameter selection. Based on the steering angle as well as the speed which we selected, the action is defined in an action space. So in this model, 15-degree steering angle with 0.75 speed limit, the action has been repeatedly used by this model which has been shown over here. And another graph which we plot during the log analysis is it's a graph between steering angle versus speed. So waypoints have been marked in an x-axis and the steering angle and the speed have been plotted in both the y-axis. See here, the first waypoint, the steering angle is in a negative degree and also the speed with the minimum speed. Then the speed is increasing, then decreasing. Suddenly, the steering angle gets changed into the positive, close to positive 15. Then immediately it has been decreased, and suddenly it goes to negative. See the graph. The progress of the steering angle is not at all stable. So this model may not perform well. And this is the heat map during the lab completion of the training. So see this graph. In most of the places, the heat map have been deviated from the regular pathway where there is a confusion is occurred. So here there is a confusion, and also here the training model is have some confusion to fix its action, and here also it is having a deviation where it has a confusion to take action. And with the minimum amount of training, this is the final, the best lab completion graph shown over here. So likewise, on each training model, we can plot various graphs. From that graph, we can predict whether the model is robustness or not. So now we are going to compare two types of training model. Both the models have trained in a time trial method in a reinvent 2018 track, and proximal policy optimization algorithm is used in a discrete action space with a maximum speed of 1 meter per second. But one model is having the training duration of 60 minutes and another module is trained for 180 minutes. Now we are just comparing both the model and we can easily identify how we can make the log analysis in a better way. So first we are checking with the convergence graph. Convergence graph is plotted between the entropy as well as an iteration, and also we are taking care of the rewards and progress of completion and completed a lab. See, so this is the first model which is trained for 60 minutes. Initially, the entropy level is very high. It is more than 2.5. Because at that time, the model is taking random actions to complete the lab. Slowly, the random action has been decreased with reference to the learning experience of this model, and it starts decreased and finally it reaches the level of less than 2.05 after 60 minutes of training. So this model is progressing. The same model is again trained for 180 minutes where the entropy point starts at 1.95. Where we left at the same position, the entropy has been started over here, and again it start to keep on decreasing. It is not at stable and it is keep on decreasing, which shows that the convergence is not yet occurred. The model is having a possibility to train more, get robustness. So this is the point we can derive from the convergence graph. And we can identify what is the action space distribution for the 60 minutes as well as the 180 minutes. Obviously, both the model is having same kind of repetitive actions over here. And see the steering angle versus speed. You just compare the steering angle versus speed graph for the reinvent 60 minutes and reinvent 180 minutes. See, there is a smooth graph which will tell about how the speed have been controlled for its various steering angle. While comparing both the graph, this is having more smoothness than this model. So obviously, well-trained model will take a smooth learning behaviors, and also the driving will be in a fined manner. And see the heat map. Reinvent 60 minutes heat map is also having some struggle to take a decision. At the same time, reinvent 180 model is also having some struggle to take the decision, but the number of struggles occurred in 60 minutes is very higher than the 180 minutes. So more training will reduce the confusions, and it will be very conscious to take the next action. And after 60 minutes, this is my path, the best path for completing the lab. So after 180 minutes, this is the best path to complete the lab. So from this diagram itself, we can easily identify which one could be the smooth and the stable model among these two. So in that way, we can utilize the log analysis to evaluate the training performance of the model which we generated, and we can take a decision whether I can stop the training or I can continue with the same training, or I can go with the I have to drop the model or go with the new model which has been evaluated from this log analysis. Hope you understand. Thank you for the journey with us to learn about the deep learning. So the assessment is waiting for you. Complete the assessment and get the credential and make your model to be on a physical track. All the best.